Well, this is going to be an intimate group, so since it is this size, I want to say, if you have any questions, just, you know, interrupt me, because I'm used to that. I assume if I hit the arrow going this way, I'll get the new slide. Okay. This picture is of Katie Bauman, and she was an inspiration not only for this speech, but also the public renewal of the STEM effort. The picture is worth 1,000 words. Just look at that face. The expression of glee, the sheer delight, and enthusiasm for mission accomplished. Katie captivated the public and was acknowledged by her role in the first ever photograph of a black hole. She is an MIT graduate, an accomplished computer scientist at age 29. You'll see her again at the end of my presentation. When I started doing research for this speech, I knew my favorite and well-known women, achievers who I wanted to highlight. I also wanted to know about women who received acknowledgement in ancient, historical, and contemporary times. I was worried that research of ancient times might prove that the individuals, due to the scarcity of written records, might prove to be difficult, but legends and oral histories produced valuable information. The historical section is mainly, excuse me, in the areas of medicine, physical sciences, and mathematics. It was a time of breaking educational barriers and women receiving degrees in the mentioned fields. The contemporary area generated an explosion of fields, interest, and many firsts for STEM women. Because of the incredible number of STEM women in this period, I developed an honorary mention category, a brief but proper recognition between longer profiles. The legendary queen He Ling Shi was the 14-year-old bride of the Yellow Emperor of China and is credited as the first to use silk as cloth. The folklore lists conflicting accounts of her discovery. One account attributed by Confucius is that while she was drinking tea outdoors, a cocoon fell in the hot liquid and began to unravel. Another is that she discovered a worm spinning silk while investigating damaged mulberry trees. In either case, she found that the thread could be unwound into long filaments, very light but strong, and she had silk reels and looms built to weave the silk thread and then the cloth. Such was the legend of what happened and developed into a long and prosperous industry of her nation. Agnes, born around 300 BC, was credited with practicing medicine in ancient Greece at a time when women were legally banned from such occupation. Some question the likelihood that she was an historic figure. Little is known about her life other than the information supplied by Hyginus, a 1st century Latin author. According to the legend, Agnes wanted to learn medicine. By cutting her hair and wearing men's clothing, she was able to become a student of the famous Alexandrian physician Herophilius. One story told of her assisting a woman crying out in the throes of labor. The woman, thinking Agnes was a man, refused her help. However, and this was repeated in several legends, Agnes lifted up her clothes and revealed that she too was female and the woman then allowed herself to be treated. Accused of illegally practicing medicine as a woman, she was defended by the women of Athens, who praised her for her effective treatments. She was acquitted, and the law against female physicians in Athens was revoked. Whether or not her tale is based on fact, it is one to which the world of medicine has long ascribed. Agnes will be remembered as the first female gynecologist. Reliable biographical information on Trotta is scarce. She lived in Salerno, a city on the Italian peninsula just south of Naples, during the 11th century. She was recognized during her lifetime as a remarkable physician, obstetrician, and gynecologist. She may have been a member of the noble Ruggiero family. Some scholars identify her as the wife of Johannes Platerius and mother of Matthias and Johannes the Younger, both medical authors. By long tradition, she is held to have written the most important and influential texts on women's medicine in medieval Europe, and is also alleged to have been the first female professor in the famous school medicine in Salerno. Anna Komnena was the eldest daughter of the Byzantine Emperor Alexios Komnenos and the author of a lengthy biography of her father's reign, the Alexiad. Although not an impartial history, her position at court and her thorough research of sources was a good measure of pithy observation and insightful opinion have all ensured the Alexiad remains one of the most popular and important primary sources of Byzantine history, covering the period from 1069 to 1118 CE. Principally a tribute to her father and his 37-year reign, the work is the only such book written by a woman in the Middle Ages. She studied mathematics, philosophy, and medicine. Now, I will be sharing some of the difficulties the women in the past or recently have faced. We all know the discrimination and difficulties and rebellions females have had to face. I've had my own experiences, fortunately not too many. I was truly sheltered in that area. After reading The Second Sex by Simone de Beauvoir, I became nauseatingly aware. The book is an excellent, I'm seeing Jenny going, yes, an excellent resource of what all Western women endured in society. Women of STEM were no different. Written in 1949, de Beauvoir was a journalist who studied math, literature, and philosophy. It is an 800-page book, but I encourage you to especially read Chapter 2, History, to be totally illuminated as to what it was like historically being a woman. It's depressing. Alessandra Ghiolani is considered to be the first female autonomist of the Western world and was reputedly the first to use the injection of colored fluids to trace blood vessels. She worked as an assistant to Mondino de Luisi, a professor of the University of Bologna, who is credited with being the father of modern anatomy. Alessandra Ghiolani's short life was honored by one of Mondino's assistants, and probably Alessandro's fiancé, with a plaque at the Church of San Pietro e Marcino in Rome, which describes her work. She was only 19 years of age. Ilana Cornara Piscopia was an Italian savant, a Venetian mathematician and a philosopher. She was one of the first women to receive a university degree and the very first to receive a Doctor of Philosophy degree, probably in the world. Passionate about learning and helping the poor, she rejected numerous suitors to focus on her pursuits. In fact, she devoted the last years of her life exclusively to the study and charity. She is honored with a stained glass window at Vassar College in New York and Jane Howard Guernsey's 1999 biography, The Lady Cornaro, Pride and Prejudice of Venice. Émilie de Châtelet was known as a lover of Voltaire, who encouraged her to study mathematics. She worked to explore and explain Newtonian physics, arguing that heat and light were related, which they are, and against the then phlogiston theory, which is assuming that all flammable substances had a substance called phlogiston, which was released when the substance burned. Total craziness. But the quote in this slide shows her drive for equality. If I were king, I would redress an abuse which cuts back, as it were, 1/2 of humankind. Laura Maria Caterina Bassi was the only one of her parents' children to survive into adulthood. She became the second woman to be awarded a doctorate and the first woman to teach in a European university. Professor of anatomy at the University of Bologna, Laura Bassi is most famous for teaching and experiments in Newtonian physics. At age 65, she was appointed to chair in experimental physics by the Institute of Physics. She died 2 years later. This brought a close to a lifelong career and a groundbreaking for women in academia. Elizabeth Blackwell was rejected by all the leading schools to which she applied. When her application arrived at Geneva Medical College in Geneva, New York, the administration asked the students to decide whether to admit her or not. The students, reportedly believing it was only a practical joke, endorsed her admission. When they discovered she was serious, both students and townspeople were horrified. She had few allies and was an outcast in Geneva. At first, she was even kept from classroom medical demonstrations as they were inappropriate for women. Most students, however, became friendly, impressed by her ability and persistence. Elizabeth Blackwell graduated first in her class in January 1849, becoming thereby the first woman to graduate from medical school, the first woman doctor of medicine in the modern era. A native of Great Britain, she traveled frequently between the two nations. In London, she met and became friends with Florence Nightingale. She became the first woman to have her name on the British Medical Register in January of 1859. Blackwell became a naturalized American citizen, and during the Civil War, she and her sister helped to organize the Women's Central Association of Relief, selecting and training nurses for service in the war. This venture helped to inspire the creation of the United States Sanitary Commission. She wrote 8 medical books, a multitude of pamphlets, and lectured continually throughout her life. Now, the first honorable mention here, Elizabeth Garrett Anderson, was the first woman who successfully completed the medical qualifying exams, becoming the first woman physician in Great Britain. She was an advocate of women's suffrage and women's opportunities in higher education, and became the first woman in England elected as a mayor. Bravo. Oh, and now we have the explosion of the last 170 years. Angelina Saini is an independent British science journalist and author. She presents science programs on BBC Radio, and her writing has appeared in many papers and magazines. She has 2 master's degrees, one in engineering, the other in science and security. How Science Got Women Wrong and the New Research That's Rewriting the Story. The title totally grabbed me. I highly, highly recommend this book, all of it. From de Beauvoir's history to Saini's research is mind-expanding. Saini's quote, "I didn't set out to write this book with an axe to grind. As a journalist, I have a commitment to the facts. And at the same time, I explore the beautiful, empowering new portrait of women that looks so different from the old one." And you are now going to see the difference from ancient and historical times. Women broke many barriers. Women received mentoring and support from their male counterparts, and most recently are strong advocates for women in STEM. We have just come so far. Just think of what we're going to be doing in the next 2-3 decades. Okay, here's one of my favorites. I cannot not show Marie Sklodowska-Curie. I was fortunate to visit the Musée Curie. The historical exhibition described radioactivity and its medical applications. I was amused by the various commercial entities and their various powders, potions, and creams. I had to laugh at one product. Its enticing description was to use the cream in the morning and afternoon for a glowing complexion. As I was reading a handwritten page from a booklet, I asked the museum docent to help me with the translation. She said, "Come with me." I was the only one there. I followed her as she took down the red velvet rope and was escorted into Marie Curie's laboratory. It was a thrill of my life. She opened Marie's notebooks and with a ticking Geiger counter showed me how they were radioactive after 100 years of her research. In fact, the year before had been the 100-year Nobel Prize World Tour of Curie accoutrements that could be taken for viewing. The notebooks and other radioactive equipment could not be taken due to the international laws regarding radioactive materials. This was also her daughter's lab. Irene and her husband, Frederic Joliot-Curie, discovered artificial radioactivity there. But on to Marie Curie. From childhood, she was remarkable to her prodigious memory, and at the age of 16, she won a gold medal on completion of her secondary education at the Russian Lycée. She married Pierre Curie in 1895, marking the start of a partnership that would soon achieve results of worldwide significance. Marie Curie was the first scientist to isolate polonium and radium. She established the nature of radiation and beta rays. She was the first woman to be awarded the Nobel Prize and the first person to be honored in 2 different scientific disciplines, physics in 1903 and chemistry in 1911. Her work led to the development of the X-ray and research into atomic particles. Her daughter, Irene, won the Nobel Prize in chemistry, making the first parent-child couple to have independently won the Nobel Prize. I get goosebumps. Marie Curie died as a result of leukemia caused by the radiation from the materials she worked with. Her contributions to physics have been immense. In 1995, her ashes were enshrined in the Pantheon in Paris. She was the first woman to receive this honor for her achievements. Her office and laboratory in the Curie Pavilion of the Radium Institute is where I got to go, and that's where they preserve all of her accoutrements. Annie Jump Cannon was the first woman to earn a scientific doctorate awarded at Oxford University. An astronomer, she worked on classifying and cataloging stars, discovering 5 novae. 2 of Lillian Gilbert's children wrote of their family life in Cheaper by the Dozen. At age of 12, I read that book and became determined I was going to become an efficiency expert. I followed many of their experiences shared by Gilbert's 2 children, including making a star chart on the ceiling of my classroom. Their father made one in the bathroom so that as they stared off into space, they would learn something at least about astronomy. However, like Curie, Lillian Gilbert followed her own pursuits and strengths after the death of her husband. She became an industrial engineer and consultant who studied efficiency. With responsibility for running a household and raising 12 children, especially after her husband's death, she established the Motion Study Institute in her home, applying her learning both to business and to the home. She also worked on rehabilitation and adaptation for the disabled. Gilbert is known as the mother of modern management. Emmy Noether was called, quote, the most significant creative mathematical genius thus far produced since the higher education of women began, unquote. Albert Einstein said that about her. Whoa. It might be that Emmy Noether was designed for mathematical greatness. Her father, Max, was a math professor at the University of Erlanger. 2 brothers became scientists as well. However, Emmy would surpass them all. Ultimately, Max would become known as Emmy Noether's father. Noether worked at the Mathematical Institute of Erlangen without pay or title from 1908 to 1915. It was during this time that she collaborated with the algebraist Ernest Otto Fischer and started work on the more general theoretical algebra for which she would later be recognized. She also worked with the prominent mathematicians Hermann Minkowski, Felix Klein, and David Hilbert, whom she had met at Göttingen. In 1915, she joined the Mathematical Institute at Göttingen and started working with Klein and Hilbert on Einstein's general relativity theory. In 1918, she proved 2 theorems that were basic for both the general relativity and elementary particle physics. One is still known as Noether's theorem. Hilbert and Albert Einstein interceded for her, and in 1919 she obtained her permission to lecture, although still without salary. Noether's conceptual approach to algebra led to a body of principles unifying algebra, geometry, linear algebra, topology, and logic. Incredible lady. Oh, I had a professor, Dr. Sylvie, for parasitology and animal ecology. He was the president of the World Health Association in the 1930s. His experiences and knowledge were exponential. It was therefore a shock to me when he quietly mentioned a lady, Libby Hyman. He shared with us that at university, national, and international meetings of biologists, there would be raucous and heated debate until one petite little lady would stand and voice her findings and sit down. Everybody after that shut up. She was the world's renowned expert on invertebrates. Who was she? A man of Dr. Sylvie's credentials, bowing to Libby Hyman. Anytime I have the chance, I share her story, as she is truly an exemplary biologist dedicated to research. Libby Hyman was valedictorian of her high school class in 1905. A zoologist, Hyman graduated with a PhD from the University of Chicago and then worked in a research laboratory on campus. She produced a laboratory manual on vertebrate anatomy, and when she could live on the manual's royalties, she moved on to a writing career focusing on invertebrates. In 1936, Hyman became an honorary research associate of the American Museum of Natural History, an unpaid position, but it provided office and laboratory space. Between 1940 and 67, she published her 6 volumes of work, as well as some 90 articles. She was the world's authority on flatworms, the most influential comparative invertebrate zoologist of the 20th century in the English-speaking world, and best known for her extensive 6-volume reference work. Okay. Excuse my tongue, but Cecilia Payne Gopashkin earned her first PhD in astronomy from Radcliffe College in 1925. Her dissertation demonstrated how helium and hydrogen were more abundant in the stars than on Earth, and that hydrogen was the most abundant, and by implication, though it was against conventional wisdom, that the sun was mostly hydrogen. Independent observations eventually proved that she was correct. In 1938, Hans Bethe formulated a fusion-based theory of how stars produce energy using her basic information. She worked at Harvard, originally with no formal position beyond astronomer. The courses she taught were not officially listed in the school's catalog until 1945. She was later appointed a full professor and then head of the department, the first woman to hold such a title at Harvard. Bravo. Her astute quote is a guide for pure research pursuits. Do not undertake a scientific career in quest of fame or money. There are easier and better ways to reach them. Undertake it only if nothing else will satisfy you, for nothing else is probably what you will receive. Your reward will be the widening of the horizon as you climb. And if you receive that reward, you will ask no other. Now that's a true researcher. Barbara McClintock, one of my favorites. Again, the transposition she first discovered in 1948 was initially thought to be unique to Mace. Her findings didn't fit in with conventional thinking on genetics, however, and was largely ignored. McClintock began studying the origins of maize in South America. Improved molecular techniques that became available in the 1970s and early 1980s confirmed her transposition theory. These jumping genes were found in microorganisms, insects, and even humans. McClintock was awarded a Lasker Prize in 1981 and a Nobel Prize in 1983. Now, I don't want you to think that because of their gender, only women suffer from conventional thinking. It's happened, and it happens now, to male scientists and who have hypothesized something that is against everyone's conventional wisdom. It takes patience and continued efforts to prove your findings. Cecilia Payne-Gaposchkin deserves another read of her last two sentences. Your reward will be the widening of the horizon as you climb, and if you achieve that reward, you will ask no other. So this is for people who are in pure research. Now, I know most of you have heard of Virginia Apgar, even though you may not realize it. She was a physician best known for her work in obstetrics and anesthesia. She developed the Apgar newborn scoring system, which became widely used to assess a newborn's health. She also studied the use of anesthesia on babies. What's more, Apgar helped refocus the Marchadimes organization from polio to birth defects. Kudos and standing ovation for this lady. Ruth Benarito worked for the United States Department of Agriculture for much of her career. She held many patents for processes to treat fibers so they would produce wrinkle-free and durable clothing. She perfected permanent press cotton, a method of making cotton clothing wrinkle-free without ironing and without treating the surface of the completed fabric. So those of us who have ironed know, we love this lady. Rosalind Franklin is another one of my favorites. She had a key role, largely unacknowledged during her lifetime, in discovering the helical structure of DNA. Her work in X-ray diffraction led to the first photograph of the double helix structure. There she made X-rays of DNA. She had nearly figured out the molecular structure when Maurice Wilkins, another researcher in Randall's lab, who was also studying DNA, showed one of her X-rays to James Watson. Watson quickly figured out the structure was a double helix, and with Francis Crick, published the finding in the journal Nature. Watson, Crick, and Wilkins won a Nobel Prize in 1962 for their discovery. Franklin, however, had died of ovarian cancer in 1958. As an undergraduate in my genetics class, Franklin was not mentioned at all. Watson and Crick had received the Nobel Prize for the double helix of DNA in 1962. As a graduate student 20 years later, I was very pleased to see Rosalind Franklin receiving the credit for her X-ray diffraction photo. It is in only the last few decades that textbooks, science professors, and online resources are giving Rosalind Franklin the credit she so richly deserved. Her X-ray diffraction photograph is to the right of her photo. and Nobel Prizes are not awarded posthumously. Annie Easley had never heard of the National Advisory Committee for Aeronautics, NACA, when she read an article about twin sisters who were human computers. And if you've seen the movie, yeah. But she was a different part. And this was at the Aircraft Engine Research Laboratory in Cleveland, Ohio. The lab, which of course was the predecessor of NASA, or NASA, was in need of people with strong math skills. And she was in need of a job, having just recently relocated from Birmingham. 2 weeks after reading the article, Easley began a career that would span 34 years. She would contribute on numerous programs as a computer scientist, inspire many through her enthusiastic participation in outreach programs, break down barriers for women and people of color in science, technology, engineering, and mathematics, and win the admiration and respect of her co-workers. When human computers were replaced by machines, Easley evolved along with the technology. She became an adept computer programmer using languages like Fortran and SOAP to support a number of NASA programs. She developed and implemented code used in researching energy conversion systems, analyzing alternative power technology, including the battery technology that was used for the early hybrid vehicles, as well as the Centaur upper stage rocket. In the 1970s, Easley returned to school to earn her Bachelor of Science degree in mathematics from Cleveland State, doing much of her coursework while she was working full-time. Easley was very dedicated in her outreach efforts at NASA. She not only participated in school tutoring programs, but was a very active participant in the Speakers Bureau, telling students about NASA's work and inspiring especially females and minority students to consider STEM careers. Sheila Tobias, lover, mathematician and scientist. Sheila Tobias is best known for her book, Overcoming Math Anxiety, about women's experience of math education. She has researched and written exclusively about gender issues in math and science education. She provides seminars as a curriculum consultant. As you can see on the slide, she has received 8 honorary doctorates and has written 14 books. Yeah, she's a marvel. Well, they all are. They're all marvels. French biologist Françoise Barre-Sinoussi helped identify HIV as the cause of AIDS. She shared the Nobel Prize in 2008 with her mentor Luc Montagnier, and for the discovery of the human immunodeficiency virus, HIV. Can't not have her on either. Sally Christian Wright, an astronaut, physics professor, engineer, author, and strong advocate of the STEM curriculum and professions for our youth. Sally Ride Day is celebrated annually on May 26th. And so we return to the beginning and our young computer imaging specialist. I hope you have noticed a trend in the STEM professions. What was once an individual's quest in isolation has now become a multi-person team effort. Katie has shared her happiness with the world, but she has also shared, I am so excited that we finally got to share what we have been working on for the past years. The image shown today is a combination of images produced by multiple methods. No one algorithm or person made this image. It required the amazing talent of a team of scientists from around the globe and years of hard work to develop the instrument, data processing, imaging methods, and analysis techniques that were necessary to pull off this seemingly impossible feat. It has been truly an honor, and I am so lucky to have had the opportunity to work with all of you. Now, science, technology, engineering, mathematics, women are there. This slide represents just a few of the websites dedicated to female scientists. I didn't even get into, well, I did see the engineering, which is wonderful, the technology, incredible, and the mathematics. So it's all there on the internet. And these are the resources as close as your friendly neighborhood county library system. The books are examples of the first 3 pages of listings out of the 50 pages shown on the website catalog. So, both websites and the library's resources are wonderful ways of exploring and celebrating our STEM women. Now, if you have any questions that I can answer, I would be very glad to. And thank you for your attention. Oh, my favorite class. They don't have any questions. No. Truly, thank you for coming. I appreciate it.
Thank you for putting us. Thank you. This is so informative.
A question about Marie Cruz's laboratory.
Yes.
So, is it shielded in any way?
Her laboratory? No, it's just, you know, bricks. She asked, is the laboratory shielded in any way? And no, it's not. Now, I assume, I don't know, that the material she was using has already been buried properly and things like that and taken care of it. But what was in the laboratory when I got to observe it, if you remember what it looked like when she was standing there, it was all clean and nice and spick and span. So it didn't have, you know, all the different materials that she did work with. So no, I'm not radioactive. I don't think. Yeah, but yeah, her fingers, you know, at the end of her life were pretty bad, pretty gross. So. All right, thank you, and y'all have a great day.